So first we need to understand that HANA is a database system. We also call it as a relational database management system. Right. So what is a first data? Then I can talk about database system. What is a data? A data is nothing but real-time facts and figures are called data. So if you want me to explain in layman language, what do you mean by real-time facts and figures is called data? For example, I go to shop. Let's say I go to Walmart, right? I'm going to purchase, for example, a milk can. Okay. Then I'm going to pay $3. Fine. So whenever you reach to the billing section, the person in the billing section is going to scan your product or is going to type in his computer, is going to enter some information, what exactly the product you have purchased and what is an amount, and is going to give a receipt to you. So what exactly this billing person is doing? He is capturing some information from you. What information is capturing? Is capturing information about you, what transaction you're doing. Based on this is capturing some data. Data is nothing but here information. So what is the real-time facts and figures here called? The real-time, the fact is I purchased a product name is called a milk can. The figure is I paid $3. This is a fact and figure. This fact and figure is providing some information to the shop person. That information they're going to store in a place called computer as a form of data. That place in a computer they're going to store in hard disk. If I want to store in a proper format, then I need a software. That software is called database management system. That is called DBMS. Guys, you might have very good experience, or you might have very good skills about the database management, or you know all these things, but please bear with me. There are few people who do not have any kind of knowledge or basics. Then we have to take care of them as well, right? So don't get bored. So this is called database management system. Then where exactly the relation is coming to the picture here? The database management system, whenever I store the data will be stored in the form of table. Okay, how this table? Table contains rows and columns. We also call it is a two-dimensional architecture. Okay, because it contains rows and columns. If you ask me how the system is getting stored the data in the form of table, the table contains rows and columns. It will be like this. Okay, so for example, let's say customer number, product, let's say quantity, whatever the quantity, or I can say price we purchased. Then we're going to store the data in the form of the table. So before HANA, all the database systems, whatever we have existing database systems, for example, Oracle, SQL, Sybase, these are all the relation IBM, DB2, these are all relational database management system. They used to store the data in the form of row storage, row wise. So they used to store the data like this: customer number, the product is milk, the price is $3. Okay, so then if I have the product information, okay, I want to, for example, if my shop got like some materials, I have to track and manage the material information or product information. Then I'm going to store this product information into a separate place, a product table. So this is also a table. So whenever the customer purchase, the product information will be gathering or capturing from the product table. So this contains the product number, product name, some like a whatever available. Okay, for example, let's say this is a product number is 1 and the product name is milk and 10 cans we have. So how do I know that when the customer comes and purchase whether we have a stock or available or not? We're going to check this information from this product table. So since I have a product number here and the product number here, for example, let's say I have a product number here. This is a P1. Then what I'm going to do is I'm going to connect these two tables to capture more information. This connectivity in between the tables is called relation. How this relation happens? One column from the first table, we call it is a primary key. The same column is available in another table, we call it is a foreign key. The primary key and foreign key can connect each other so that I can read the data based on this primary key, which provides information into other columns. So this connectivity is called joins, we can also call, or we can also call relations. That's the reason we call it is a relational database management system. Okay, so this is a basic concept of how the database works in real life and how the data gets stored back in your database system. And every database contains a table. All the data gets stored in the form of table. Okay, so now the question is, when we have this very good infrastructure and architecture of other database systems, what made exactly SAP to introduce a new database system called HANA? The reason, because we have already discussed in a demo session, as HANA provides a much faster access to your data. This is exactly what we are going to cover here. So what makes exactly HANA is much faster? The first thing is we have to understand that HANA is a combination of software and hardware technology, which providing both these features to run the product in much faster comparing with other database systems. So when you talk about hardware technology, in especially in HANA, how this HANA hardware has been built, then we have to talk about the multi-core architecture. HANA has been designed in the foundation of multi-core architecture. Multi-core is nothing but 8 core for one single CPU. So 8 CPUs will be one server. So totally 8 into 8 core CPU in one single server. So multi-core architecture, I'm going to discuss more about this. And we have a massive parallel scaling with the number of blades. We also call it as a blade server. One blade server is equal to one enterprise class server. So don't get worry about this technical part. We are not going to work in real time with technical or hardware system. We have to understand the concept. And the second major information in hardware technology is called the in-memory capacity, the in-memory database, in-memory data storage in HANA. So how this in-memory storage will happen, we're going to discuss about here. So whenever you talk about the multi-core architecture, if you go and see this, for example, I have a table. A table contains a column A, B, and C. So since I have a multi-core architecture, the table columns has been divided per each core. For example, since I have a 3 columns and the core 1 has taken 1 column, I told you that 8 cores I can keep into one CPU in one system, right? That is called architecture, your motherboard architecture. So one column is reading or processing the data has been taken care by one core. The other column will be taken care by other, but the column C has a more distinct value. It has been divided into two parts and taken care by the two different core system. Now you can understand that if I want to start processing the data, or if I want to start reading the data, these multi-core systems are taking care by each column, so it will process the data on time and much faster way comparing with the traditional database systems. It is a very simple. For example, I have a bunch of people in one single room. That, for example, I want to find out how many people are there. So to enter inside the room, it is not possible. If I ask them to come out from the room, since I have only single door, then all the people start coming out from the room is not possible. Then what happens? The process will become little slower. What in case that particular room contains a 4 to 5 different doors? I can open all the doors, all the people can get in much faster way comparing with the previous situation. The processing speed is increasing. The reason because this core systems, the core is taking care, the hardware technology is taking care by the table, it's splitting into different parts and reading the data, writing the data is taken by each core. So there is no much dependency on the server load or server like a performance. So the server performance will be much lighter and much faster since the system is taking care, our system is dividing the data and reading the data into different parts. This is called multi-core architecture. Then coming back to this RAM, the RAM contains almost like each RAM capacity you can keep it up to maximum 2 TB of RAM into a particular HANA system, but minimum we go for 128 GB. In real-time situation, the minimum RAM capacity we use 128 GB, the maximum up to you can go for 2 TB in current versions. So what happens here is, since I have in-memory capacity, I can control whether the data has to store in the memory whenever I require. I can clean up the data, I can make my RAM space free, I can remove the data. So these kind of operations can be controlled by your HANA consultant. So we have everything in our control. So we don't need to worry about that one. This process is going to take care of the system. No, still I can decide what data has to sit down in the RAM till what time. When I don't want to, like when I don't require the data has to be sit down in the RAM, then I can say clear it. I can delete it. So these kind of operations can be performed. Then it will be much flexible for you to manage your data. So I don't feel that my RAM is getting filled up with the data. So I can clean as long as when I don't require the data, right? So that's the reason it provides some more space for you to store the data, since it's a 2 TB of RAM, and we can also schedule unload the data whenever I don't require it. So these features will be providing you much flexible for you. Coming to the software technology. Software technology provides a row and column store. You can ask me a question, don't we have a column store capacity or column store feature in a previous or traditional database system? Of course we have. We used to have in a traditional database systems, but the people are not aware of it, how to use it. When the HANA introduced, then people started getting familiar with the word called column storage. I'm going to talk more about what is a column and row store. Then the data compression, the data partitioning, and aggregation of the data, and the delta mechanism. These software innovation is making your HANA is running much faster way. Let's talk about each one by one. See, for example, let's say that I have here a system, HANA system. Let's say that how the data gets stored and how the data system is reading the data. For example, let's say in HANA, I have a main memory which is called RAM, and I have a data volume which is called my hard disk, and I have a log volume which is also called hard disk. So what happens is all the read operations can be happened from the RAM. All the write operations happens in your hard disk. Since the data is reading from the RAM, it is much faster. If you go back to the traditional systems, whenever I insert any record, the record goes to the RAM, then it will send it back to the data hard disk, then hard disk gets stored here. Whenever I want to read the data, then system will first we have to input the instructions, informations has to be given, input commands. The system will send this input instructions to the RAM, then it will send it to the hard disk, read the data, send it back to the RAM, send it back to the output storage, like output device. Fine. So this process is taking a much time consuming, right? So that's the reason whenever I keep the data inside the RAM, if I'm reading the data directly from here, not from the disk, then the data reading time increase much more. If you ask me that the difference in between the reading the data from the hard disk and the reading the data from the RAM, there is a 1000 times faster reading the data from the RAM comparing with the hard disk. This is where exactly HANA, the real feature of HANA comes to the picture. Okay, this is what exactly making HANA is a hot cake in the market, because the fast, how it is running, because the data is reading from the RAM. Okay, let's come to this, how the data first in a HANA system, whenever I insert a record, how the record getting processed, how I'm reading the data, how the system is understanding this feature. So let's talk about this one. First, whenever I insert the data goes to the RAM, but it will send it to the hard disk. So the writing operations happening in the hard disk. Okay, then what happens is, for example, I have a table here. So when I insert the first two records, the RAM will send it to the hard disk, and the meanwhile, whenever I'm adding another 4 records, so whenever I insert the 2 records, what happens is the log will be inserted into the log volume saying that there are 2 records or 3 records has been inserted. Whenever I'm inserting another couple of new records, 4 records, then what happens is immediately it creates a one statement or line in the log volume. There are 4 records has been inserted. Then in this time, whenever I say commit, then only the data goes and stored into the hard disk. For example, I forgot to say commit in the sense saving the records. Then I lost the power. Then what happens? As RAM is a temporary storage area, it is volatile, so you're going to lose the data here. So I lost the 4 records. So there is no chance of getting a 4 records back, right? But whenever I restart my system, then what happens is the system will go and read the data from the data hard disk and send it to the RAM only for the first time whenever you restart the system. When the data reach to the RAM, the next operations onwards, for example, let's say I want to say select star from so and so table. Then what happens? The system SQL statement comes to the reach to the hard disk and read the data and send it back to the RAM. Then it will send it back to the output device. But next time if you again say select star from the so and so table, the second time it doesn't go to the hard disk. Since the data is here, it will start reading from here. Okay, now what about the last records? Whatever the 4 records I have lost it. Whenever you restart the system, it is going to capture the 2 records and keep it into the RAM, then goes to the log. It will read what was happened the last time whenever I lost the power. I was inserting 4 records. This log volume will be applied, returned back to the RAM. Then the RAM will get 4 records. Now if I say commit, the 4 records will come back and store into the data volume. Now I will get 6 records in my data volume. Okay, so what happens, how the system knows that whenever I restart my server, the system has to go to the data volume and read the data and send it to the RAM. How the system knows this? There is a feature called preload, which we have to set up in your server. The preload flag, if you flag can be set it up preload. Whenever we restart the server, the system will go on preload the data from the data volume and back to the RAM. Okay, so this is what exactly is happening whenever you are running the server, whenever you lost the power. So I have almost I have one more option also. Whenever I want to load or unload the data also, by manually I can load the data from hard disk to the RAM. I can unload the data also from here. To unload, I have one more functionality called unload priority, which I can set up some scaling capability here 0 to 9. For example, if I set up, for example, let's say unload priority is 0. So when I can go for this option, let's say I have a 1 TB of RAM. My RAM got full of data. It's filled up with a lot of data. So what I feel is I don't want to keep all this data. So whenever I read the data should get clear automatically. Then I can write a command, or whenever I create a table, the table I'm going to keep it unload priority, for example, let's say 1 or 2 till 9. So whichever the number you kept it low, Whenever the table get created and load, then what happens is it will automatically unloads whenever it is not required. For example, if there is a more data, if you keep adding, if there is no space in your RAM, the based on your unload priority, those tables, wherever you set up this unload priority flag, those tables get clear automatically from the RAM. This is called data persistency. There is also one more thing called save point, where I can set up certain the minutes here. So every 5 minutes I want to save automatically the data so I don't lose the data. There is a one more question: what happens if I lose the data in the hard disk or the log volume? No need to worry about this one. Your HANA administrators will take care of the backup on regularly on every day in your data center. So whenever I lose the data in a hard disk or hard disk get crash, then what I can do is I can always take a backup and reload back to my hard disk. Then I'm not going to lose any data. But whenever I lose the RAM, there is no backup for this. I can say that my log volume is going to work as a backup for my RAM to write back this log to my RAM system. Fine. So this is called data persistency. When you come to this row store and column store, what is this? And if you ask me here, HANA supports both row store versus column store. If you ask me, it is supporting both. While you creating a table in your HANA database, you have to decide whether you want to create a row store column table or you want to create a column store table. So let's talk about how the row store table works, how the column store table works. For example, let's say that I have here a column store. I have a table here. The table contains a certain columns: country, a product, and sales. And the countries I have around, like I can say that there's certain values are there. So this particular table contains row 1, 2, 3, 4 rows it has. Each line of the data is called one row. The horizontal. The vertical lines is called column. It contains 4 rows in this particular table. Okay. So whenever I store this data in the database, how the data is getting stored in the memory. That is a major concept. If it is a row store table, it will take one row. For example, I have a row 1 here, India, chocolate, and 1000. So it is taking a first row and it is organizing the data first row. Then it will take the second row data, then third row and fourth row, and so on. So this is how the row store stores the data in the memory. When you come to the column store, since it has only 3 columns, country, product, sales. So the column store table stores the data in memory as a column wise. So it will take whole the column and stores the data. It will take whole the columns, second column, third column. Now let's start finding the difference. If I want to read or write the data, which is a much faster, please remember we are going to use HANA as an analytical system, right? So analytical systems, most of the time we read the data. We don't create the data. Okay. So let's keep that in mind. Let's talk about this, which is a much faster. For example, let's say that I want to find out a particular record. Let's say that I'm going to write a SQL statement, select star from a table where country equal to Germany. So what does it mean? If I write that command, okay, let's say I have here country, I have a product, I have a sales. Okay, if you take this as a table, let's say I have here country India, US, Germany, UK, and you can say China. Let's say I have a product chocolate, milk, pen, paper, phone. So now these are called rows, these are called columns. If I want to read a particular, for example, I want to read where the country equal to UK. I want to read what UK has a product. Then I'm going to write a SQL statement. Select star from where country equal to, let's say I'm going to say UK. What does it mean? It means that I want to read only this particular row. Okay, so I don't want to read all the data. I want to read this particular row. Guys, can you hear me? You have any issues with the audio? Is it clear for everyone?
Yes.
Okay, great. So when I write this particular statement, the statement is going back to the database and it is trying to pull this particular information. This is a result for this particular statement. Okay, let me get this. So what is the result here? It is reading one particular row. So in this kind of situations, what happens is the row store is much faster. The row store is much suitable for this. So it is going to read the particular where this UK is there. It is going to read that particular information much faster way. Okay. Let's say I have one more situation here. I'm going to write one more statement. Select country from table. So what I want here, I want all the countries from a table. Then now tell me either it is easier in a row store or column store. Which one is easier? I want to display all the countries. Sorry?
The column.
Column store.
Column.
Wonderful. Right? So in this particular situation, the column store is providing you a good results to you. The reading the data is becoming much faster. Right? So this is the reason why we have to understand that whether I have to create a row store and column store. Row store, let me give you one more example. I want to insert a data, one record. Let's say that I want to insert a Japan. Insert into values like, let's say I'm going to say Japan. Don't worry the syntax, I'm not writing the proper syntax. So Japan, let's say I'm going to write product is phone, right? Let's say laptop, and the cost is 600. Now tell me how the data will be inserted here. The data is going to insert Japan laptop and 600. How the data is getting inserted here? In the row wise. It is going horizontally, right? So inserting time, the data is getting inserting in a row wise, so it is much faster. So what does it mean? Row wise column stores are good for writing the data. Column store tables are good for reading the data. As I'm using SAP HANA as an analytical system, sometimes I have a tables thousands of, let's say I have, for example, 50 columns. Do I need all the columns to read? No, I have to read only for example 3 columns. Then which is a much suitable for me? Is it a row store or a column store? Can I have a quick answer?
You said you're talking about just 50 columns.
Columns. See, I'm giving a scenario for you again. For example, my table contains 50 columns, but I don't require to read all the 50 columns. I'm going to choose only 3 columns. Then at the time, Which table is
Row.
suitable for it? It's a column
Row.
store. When I'm talking about a column store, it is a column store. So I'm reading only a couple of columns, not for all the columns, right? Not all the rows. So then the column store is easy. Since HANA is an analytical appliance, we most of the time we read the data. This is the reason SAP said that whatever the table we create in HANA, by default table type is column store by default. But still you can change to row store or column store. Still I have option. It's up to you. But if you create any table, by default the table type will be created as a column store. Then coming back to here, let's say that I have a column store table. The column store table is storing the data in a column wise. Okay, now I want to read in a column store where, for example, let's say I have a Germany. I want to read the Germany related data. So the system, I'll say how the system will go and read the data here. The Germany is here and the chocolate belongs to here and the chocolate values is here. How the system is going to identify what is a suitable value for Germany under product, under sales. The system has an option called position indexing. So whenever you store the data in a column, it is going to give you some numbers for the columns. Based on the numbers, that is called position indexing. Based on this, the system is going to identify where is a suitable value for this particular column in a particular record. So it is automatically identify and give you the values to you. So you don't need to worry about this one, how this position indexing is going to create and everything. It will be taken care by the system. So this is the reason always the column store is much comfortable or much flexible for reading the data. That's the reason by default HANA has a column store tables whenever you start creating. Then is it clear for you what is the difference in between column store and row store, which is a much faster? Any questions here?
No.
Yeah, Triveni, any questions from your end? Ram?
Nope.
Okay.
No, I'm good. Yeah.
Okay. So now let's come to this column storage. What is the main features is available in the column storage? When you talk about the column storage, the main features here is whenever you say the column storage is getting into the memory, the main memory has a certain options here. Whenever you write the data, how the data getting writing, how the data getting reading from the memory, especially from the column storage. When you see here, the column storage in a main memory, it contains two different I can say blocks or storages. One is called delta block and main block. So whenever I insert a record, all the write operations happens in the delta, and the delta will send this information to the main storage. Whenever I start reading the data, the reading operation can happen from the both places, main and delta. So what does it mean? All the write operations happens in the delta. So when I insert one record comes and stores here. So like this, whatever the records I'm going to insert, all the records first get placed into delta. Whenever I have a free time, I can say delta merge. When I do the delta merge, the data will be sending to the main storage. Then the reading happens from here and the delta also. So reporting goes most of the time from here. So what you need to understand here is it is going to provide you, since it is going to give you two different storage options to you, main and delta, it enables you high compression of the data, high write performance at the same time. You need to understand that the writing operations and reading operations are not happening from one single place. Since it is happening in two different places, it is going to improve your performance, especially your writing performance, and the most of the time reading performance as well. So the write operations, only in delta storage we're going to write the data, so it is write optimized. The update is performed by inserting a new record into the delta storage, so automatically the delta storage get update this information, and unless until if you don't say merge the delta, it won't send this information to the main storage. Whenever you have a free time or whenever we have a scheduled time in a database, I can say delta merge, then the data will be transferred to the main storage, then the system can start reading from here and here. If I don't do the delta merge, then what happens? If I want to read the data, is it possible from the delta? Yes, I can still read the data from the delta itself, even though I don't have any data in the main. And data compression in main storage, when you talk about this one, compression by creating a dictionary and applying further compression, it is going to speed up your loading the data into CPU cache. So reading operations, because the writing operations is not happening here. So it's only reading the data. So it will always look for in the main storage whenever you start reading the data. When the main storage is not available, then the system will look for the reading operations from the delta storage. The read operations always have to read from both main and delta storage and merge the results. Engines uses multi-version concurrency control, MVCC control, to ensure the consistent and read operations are performing accurate. So this is how exactly your column store is going to provide you. This is one of the major feature to you, where it is splitting the operations into two different storage capacities. That's the reason it is going to increase your speed, server performance, reading operations and writing operations. This is all about your column storage. Any questions here?
Nope.
Is it clear for everyone how the system is reading?
All good.
Okay, so if you understand this concept, then I can start writing. Whenever I talk about delta merge, we have a good topic, one subject called delta merge. Then you should understand this, how the delta merge is happening, what is a delta, what is a main storage, where the write operation happens, where the read operations happens. Okay, whenever I say there is a delta merge process, how this delta merge process is going to happen. Let's say I'm going to give an examples to you. First, before merging the delta, we already discussed about how the data will be there, right? The data will be there initially in a delta. Then whenever I say merge, how the data will be sending to main storage. That is going to happen in the during merge. In the during merge operations, all the write operations are there in the delta, right? So what happens is, it is going to create two new storages. This is a main and delta is a previous storage where we have it. It is going to create again a similar storages. So right now we have a 4 storages, which is called main new, delta new. So what happens here is, all the write operations happens in the delta new. What happening here? This delta process is sending the data to main at the time, since it is becoming a busy. So I don't want to get more performance on this. Then system is creating one more storage called delta new, where it is taking a write operations. Of course, it provides read operations while it is like a merge operations is happening during the merge operations. Once the delta will clear all the records sending back to the main, then what happens, system will delete this old main and delta feature, and it will keep this main new storage and delta new storage. Now whatever the data was here, now it is available here. After this is how the system look like after the merge. After the merge, if I have a 5 records earlier here, I am automatically getting 5 records here. Now my delta new is ready for write operations, and both are ready for read operations. This is how the delta merge happens before merging, the during merge and after merge. Any questions here? All good. Great. So this is a basic information before starting our codes. How this behind the system, what exactly happening, how the data is getting stored, how the data is getting read, and what are the components is going to help us to process my data to reading or write operations. This is a major important. Okay. So once you've done this one, the next topic is, we need to understand. Yeah, it is in memory. So now HANA components. So whenever I want to work with the HANA, how many tools I'm going to work? That is called components. So basically we have a HANA database server. Then we have a HANA Studio. Okay. Then we have a reporting tool. Okay. So these are the major. If you talk about HANA, reporting tool is not belongs to HANA. This is the two things we have. Of course, we have a SLT, DXC, MDX. These are all the connectivities drivers, or you can call. So this is a server which provide a service. This is a client which we can perform all the read and write operations from here. So I can also call it is a backend system, and I can also call this is a front-end system. Okay, so most of the time I'm not sure what is this. So if I want to start working on this, let's say for example, I have a HANA database system. This is a database system. Okay, database system. Most of the time we'll say connect system. We have to get familiar with these words. What do you mean by connect system? Connect system is nothing but connecting to database. That is called connect system. Okay, add system. I can also call add system. Okay, what does it mean? Adding a system, connecting a system is nothing but connecting to a database. So this database is blank initially. There won't be any data. So I cannot directly jump into the database and open and read and start creating the data. So what they decided is they have given one graphical user interface. We also call it is a GUI. Okay, so this is called GUI. This GUI is called HANA Studio. What I can do with this? By using this particular GUI, I can start connecting to my HANA database. When I start connecting to my HANA database, then what happens is I can see this database here. This is called system. Now I have my system inside my HANA Studio. So now what I can do? Can I do any operations, read and write operations here? Yes, I can do write operations, I can do read operations, I can manipulate the data, I can do anything. So I don't need to go back to here. This is our tool which is called HANA Studio, where I can start designing my database. Designing of your database is called modeling. HANA, we have a first topic is called modeling. What is a modeling? A modeling is nothing but, if you ask me, designing a database is called modeling. What do you mean by designing a database? Let's say that I told you first initially, whenever we do implementing HANA database, it is a blank. What do you mean by blank? No data. It's absolutely blank. No data is available. So then what I need to do? You have to start looking for where the data is available. So where the data is available, always the data is available outside of your database system. So it is available in SAP systems and non-SAP systems. What is SAP systems? SAP systems are nothing but ERP, CRM, BW, blah blah blah. Okay, what is a non-SAP systems? Oracle, Sybase, or any RDBMS. I'm not going to write all the things. Any RDBMS systems and flat files. What is a flat file? Flat file is nothing but your Microsoft Excel. Even if I have a data in a Microsoft Excel, I can load this data. So what I'm going to do this one, we are first identifying where is the data available. So data available in SAP system. Then I have to start connecting to my database. So whenever I want to start connecting to database, we are not going to connect to directly database. No, we are connecting to HANA Studio. In a HANA Studio, we are creating this connection. The connection information will be created in HANA Studio even from non-SAP systems. Same thing. So we have a various of connections are available. Let me talk about each connection. Okay, if it is a non-SAP systems or any other things, we can have always BODS, SLT systems. Okay, BODS we have, it is an open ETL tool which I can connect to any systems. And what about this? We have also DXN. What about SAP systems? We have SLT, BODS, then we have also MDX, we have also DXC. These are all the connectivities which we have, and tools also I can call. What is SLT? SAP Landscape Transformation Server, which we can call it, which you can use for real-time extraction, or we can say real-time replication. What does it mean? If any record get created in SAP system, the record immediately available in your HANA database and immediately available in a report. That can be taken care by this SLT. We have a very good subject this. We have a big topic on this. We're going to discuss more about this in coming sessions. Okay, so this is a way how we are going to extract the data and loading the data. Now after loading the data, what is the modeling? How the data is getting stored in the database? For example, let's say I have a table here in one database. Let's say it is a customer number, name, address. For example, let's say C1 given, let's say US, C2 Kumar, let's say UK, C3, for example, let's say John, let's say again US. If I want to load this data, so what I need to do first? I have to start creating a structure. What is the structure I have to start creating? Exactly what data you want to load. Let's say, for example, if I don't create structure, what happens? I want to load the data. Let's say I'm not going to create a structure. I'm loading the data into my HANA database. Sorry. I'm not going to create any structure. I loaded the data. So it's the same data. I have not changed anything. Okay, I'm going to talk about this MDX and DXC. It's a multi-dimensional connection, direct extraction connection. These are the connections which can help you to extract the data from various SAP systems. We have a separate classes for this. So now it is only basics. I'm just giving the words to you. Don't worry, we are going to discuss in depth of those things. Okay, so when you come back to here, I'm extracted the data. I have extracted the data without any structure, but I have not changed the data information here. It's the same data. But can you understand here, if you, for example, if you call someone, if you ask him what is a C1, he will say it is a customer number. If you ask him what is a Kiran, he will say it is a customer name. If you ask him what is US, it will say address. The same information you can ask him what is a C1. He says I don't know what is this. Why? Since it is the same data here and there, why is not able to identify what is a C1? The reason because it doesn't have a structure. So what does it mean? It means that the loading the data is not important. Okay, the loading the data properly is a main important concept here. So if you want to load the data, the first thing what we have to do is we have to create the structure. Then only you can start loading the data. So first thing is we have to create the structure. This is called table columns. Now the table has a proper format. Then I can start loading the data. Like automatically the data comes and get loads here. Now once I do this process, now my data has a meaningful information. So what does it mean? to load any data, first you have to create a structure. This is called definition of the table. We also call it as a metadata. So first we have to create a definition of the table, then you can start loading the data, then the data get a meaningful information. The way of you creating this table then you are reading this data, it's called nothing but modeling. Modeling is nothing but designing of your database. See now, once I create the structure and I load the data, my database got a design of one beautiful table here. So my database is getting designed automatically. My database got designed. So what does it mean? I have modeled my database. So I have designed my database according to my business requirement. That is called exactly modeling. So this is what we're going to learn, how to create the tables or how to load the tables. After loading the tables, what are the options are there in a model? It's one of the biggest topic we're going to discuss more in detail in coming sessions. So what I'm doing here is I'm going to stop the class here. There are few more people supposed to join. So today I'll be taking very less time. So I have stopped it here. But in a coming session it will goes for 2 hours. So now it is a question and answer sessions. If you have any questions, any topic is not clear, you can discuss with me. Yeah, you can unmute yourself. You can start the session little early. Who's this? 9 p.m. EST. Okay, I'm not sure because there's a people requesting for 9 p.m. So we put it as a 9 p.m. Oh, any issues with 9 p.m.? 9 p.m. CST?
Actually, I mean, it's
One
yeah,
second.
and it'll be little late. So I was just wondering. I think maybe the three men also want to have the same impossible.
Okay, but I have a one session. It's 8 to 9 p.m. So 9 p.m. is CST is going to be 10 p.m. EST, right?
Right.
So I
I
think
think it should be fine. Or what do you think?
I'm sorry, you're saying something?
Yeah, I was saying that it should be okay. I don't know whether he is comfortable with 8, but it should be fine.
Okay, but the thing is, I have already a class at 8 to
Oh,
9
okay,
p.m.
okay.
Uh, let me discuss with them tomorrow. In case if they are okay with this, I will move that batch to 9 to 10. Then I can move your batch little early. I have to discuss with that batch. We can work on it.
Yeah, sure.
Yeah. So guys, I just want to get the clarity on this. You got some concept today, right? How the system is working? Is it clear for everyone?
Yes.
Yeah,
Yeah,
it's
that is
clear.
what exactly we
There
want.
are more questions, but I think we will encounter those later.
Oh, it's okay. In case if you have any questions right away, if you would like to discuss, you can go ahead. No issues.
I was wondering like how data would come from web services, which is an XML format,
Mm-hmm. Yeah,
and
yeah. Triven,
and the XML format is like having multiple ERD relationships and so on.
yes. Triven, see, the class is today we're just talking about basic things. And we have a
Yeah, yeah.
class is divided into 3 parts. Let me give you that clarity to you. This class will be divided into 3 parts. Modeling, extraction, reporting. The complete course has been divided into 3 parts. In extractions, we're going to discuss about all the features, how many ways we can extract the various different types of data. So at the time, whatever the questions you have related to extractions, everything will be clear for you.
Okay.
Okay, so today I was just introducing you how we can get the data from, how we can create the connections, how we can get the data. It's a very basic introduction today.
Yeah, yeah.
We have a separate, it's a big topic actually. It's a big topic. We're going to discuss all the options, how many ways I can extract the data into HANA.
Mm-hmm.
So Kiran, you said it's a two. So we'll have a 2 hours daily. So how many days of course is this?
It goes for 1 month.
Okay.
It will be totally 45 to 60 hours of duration. Sometimes if it is required, it goes more than that also, but 2 hours is enough.
Okay.
We
So
can
we'll be taking classes in the weekend also.
if you guys are comfortable, I can take on weekends, but I have to check with all the people
Okay.
because most of the people, they don't willing to spend on weekends, right?
Yes, that's right.
Yep.
I know that. I know that. That's the reason I'm telling you. I have to discuss with the people. If everyone is okay, then we can. Otherwise, we'll go on Monday to Friday.
Okay.
And guys, I'm going to provide you the server access to you by today at night. And you will get the server access. Tomorrow we start opening the HANA Studio tool. We're going to walk through all the features and navigation information what we have in a HANA Studio. Then we start working on it. Fine. Any more questions?
No more from me.
Okay, great. Cyril, do
Thank
you
you.
have any questions?
No, I'm good.
Oh, great. Thank you very much. And Ram, of
Yes,
course, Ram, is it clear for you, Ram?
Yes, yes, it is. Thank you. Yep.
Great, fine. So I'm going to send you this the recording sessions